students, myself Arti KS. I am going to present the video on the subject Fundamentals of Computer. Subject code 20 CS 11T of first semester belongs to Computer Science and Engineering on Unit 1 Basics of Logic Design. Topic is conversion between decimal number system and others. Next we move on to the table of contents. First one, decimal to binary, decimal to octal, decimal to hexadecimal, binary to decimal, octal to decimal, and the last one is hexadecimal to decimal. Next we move on to the conversion between decimal to binary of integer number. ಈಗಾಗಲೇ ಫಸ್ಟ್ ಸೆಷನಲ್ಲಿ ಓದಿರ್ತೀರಾ, ಯಾವುದೇ ನಂಬರ್ನ ಬೇಸ್ ವ್ಯಾಲ್ಯೂ 10 ಇದ್ದಾಗ ಆ ನಂಬರ್ನ ನಾವು ಡೆಸಿಮಲ್ ನಂಬರ್ ಅಂತ ಕರಿತೀವಿ. ವಿ ವಿಲ್ ಸಿ ದ ಡಿವಿಷನ್ ಮೆಥಡ್. ಫಸ್ಟ್ ಸ್ಟೆಪ್, ಡಿವೈಡ್ ದಿ ನಂಬರ್ ಬೈ 2. ಯಾವುದೇ ಡೆಸಿಮಲ್ ನಂಬರ್ ತಗೊಂಡಾಗ ಆ ನಂಬರ್ನ 2ರಿಂದ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್, ಪುಟ್ ದ ರಿಮೈಂಡರ್ ಆನ್ ರೈಟ್ ಸೈಡ್. ಬರುವಂಥ ರಿಮೈಂಡರ್ಸ್ನ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ ಹಾಕಬೇಕು. ಥರ್ಡ್ ಸ್ಟೆಪ್, ಕೀಪ್ ಡಿವೈಡಿಂಗ್ ಅಂಟಿಲ್ ದ ಕೋಶೆಂಟ್ ಬಿಕಮ್ 0 ಆರ್ less than 2 is reached. ಡೆಸಿಮಲ್ ನಂಬರ್ನ 2ರಿಂದ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಕೋಶೆಂಟ್ ವ್ಯಾಲ್ಯೂ 0 ಆಗೋವರೆಗೂ ಅಥವಾ ಕೋಶೆಂಟ್ ವ್ಯಾಲ್ಯೂ 2ಕ್ಕಿಂತ ಕಮ್ಮಿ ರೀಚ್ ಆಗೋವರೆಗೂ. ಫಸ್ಟ್ ಸ್ಟೆಪ್, ರೆಕಾರ್ಡ್ ದ ರಿಮೈಂಡರ್ಸ್ ಫ್ರಮ್ ಬಾಟಮ್ ಪೊಸಿಷನ್ ಟು ದಿ ಟಾಪ್ ಪೊಸಿಷನ್, ದಟ್ ಈಸ್ ಫ್ರಮ್ MSB to LSB to get the answer. Next we move on to the conversion between decimal to binary with an example. Take the decimal number 26 base value 10 into its binary. So take the decimal number 26 divided by 2, quotient 13 and remainder 0. We will get that should be put it on the right hand side, that is LSB bit position. Next, take the previous quotient 13 and divide it by 2. Quotient value 6 and remainder is 1. Takes the previous quotient 6 and divide it by 2. Quotient value 3 and remainder is 0. Takes the previous quotient and divide it by 2. Quotient value 1 and remainder 1. Takes the previous quotient 1 and divide it by 2. Quotient is 0 and remainder is 1. Hence, we can read the position of the remainders from bottom position to the top position. Therefore, 26 base value 10 is equal to 11010 base value 2. Next we move on to the conversion between decimal to binary of fractional number. First step, for fractional decimal numbers, multiply it by 2 and record the carry in the integral position. For any fractional decimal number, multiply it by 2 and record the carry in the integral position. Second step, the process is repeated until the fraction becomes 0 or till you reach the sufficient accurate value. The process should be repeated until the fraction value becomes 0 or till we reach the accurate value. Third step, the carry when read down produces the equivalent binary fraction. So whatever the carries that we have got, that should be read from top position to the bottom position. Take an example. Decimal fraction 0.188 to binary. Take 0.188 and multiply by 2 according to the first step. It is equal to 0.376. So take the value 0 and put as a carry. Next, take the previous value 0.376 into 2 is equal to 0.752. So take the value 0 and put as a carry. Next, 0.752 into 2 is equal to 1.504. So take the value 1 and put as a carry. Next, take the previous value 0.504 into 2 is equal to 1.008. Take the value 1 and put as a carry. Next, take the previous value 0.008 into 2 is equal to 0.016. So take the value 0 and put as a carry. Hence, we can read the position of the carries from top position to the bottom position, that is 0.00110. Next we move on to the conversion between decimal to octal ಆಫ್ ಇಂಟೀಜರ್ ನಂಬರ್. ಯಾವುದೇ ನಂಬರ್ನ ಬೇಸ್ ವ್ಯಾಲ್ಯೂ 8 ಇದ್ದಾಗ ಅಂಥ ನಂಬರ್ನ ನಾವು ಆಕ್ಟಲ್ ನಂಬರ್ ಅಂತ ಕರಿತೀವಿ. ಫಸ್ಟ್ ಸ್ಟೆಪ್, divide the number by 8 until the quotient becomes 0 or less than 8 is reached. ಯಾವುದೇ ಡೆಸಿಮಲ್ ನಂಬರ್ನ ತಗೊಳ್ಳಿ, ಆ ನಂಬರ್ನ 8ರಿಂದ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಕೋಶಂಟ್ ವ್ಯಾಲ್ಯೂ 0 ಬರೋವರೆಗೂ ಅಥವಾ ಕೋಶಂಟ್ ವ್ಯಾಲ್ಯೂ 8ಕ್ಕಿಂತ ಕಮ್ಮಿ ರೀಚ್ ಆಗೋವರೆಗೂ. Second step, writing the reminders from bottom to top gives the octal number. ಬರುವಂಥ ರಿಮೈಂಡರ್ಸ್ನ ನಾವು ಬಾಟಮ್ ಪೊಸಿಷನಿಂದ ಟಾಪ್ ಪೊಸಿಷನ್ವರೆಗೂ ರೀಡ್ ಮಾಡಬೇಕು. ಸೊ ಟೇಕ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್, ಕನ್ವರ್ಟ್ ದಿ ಡೆಸಿಮಲ್ ನಂಬರ್ 256 into octal. Take the decimal number 256 and divide it by 8. Follows from the first step. We will get the quotient 32 and remainder 0. Again, divide the quotient 32 by 8. We will get the quotient 4 and remainder 0. So here we have stopped dividing further because the quotient value 4 is reached less than 8. So the remainders can be read from bottom position to the top position are 4, 0, 0, base value 8. Next we move on to the conversion between decimal to octal of fractional number. First step, multiply the decimal number by 8. You take any fractional decimal number that should be multiplied by 8. Second step, the process is repeated until the fraction becomes 0 or till you reach the sufficient accurate value. Third step, reading the carry downwards gives the octal fraction. Whatever the carries that we have recorded, that should be read from top position to the bottom position. Example, convert 0.23 base value 10 into octal. So take 0.23 multiply by 8 follows from the first step is equal to 1.84. So take the value 1 and put as a carry. Next, takes the previous value 0.84 into 8 is equal to 6.72. Take the value 6 and put as a carry. Next, take the previous value 0.72 into 8 is equal to 5.76. So take the value 5 and put as a carry. Hence here we have stopped multiplying because we have reached some accurate value. So the position of the carries can be read from top position to the bottom position, that is 0.165 base value 8. Next we move on to the conversion between decimal to hexadecimal. ಯಾವುದೇ ನಂಬರ್ನ ಬೇಸ್ ವ್ಯಾಲ್ಯೂ 16 ಇದ್ದಾಗ ಅಂಥ ನಂಬರ್ನ hexadecimal ಅಂತ ಕರಿತೀವಿ. We'll see the first step. Divide the decimal number successively by 16 and writing down the remainder. ಯಾವುದೇ ಡೆಸಿಮಲ್ ನಂಬರ್ನ ತಗೊಂಡಾಗ ಆ ನಂಬರ್ನ 16ರಿಂದ ಡಿವೈಡ್ ಮಾಡಬೇಕು. Second step, repeat the process of division by 16 until the quotient becomes 0 or less than 16 is reached. So process of division na continue ಮಾಡಬೇಕು. quotient value 0 ಬರೋವರೆಗೂ ಅಥವಾ quotient value 16ಕ್ಕಿಂತ ಕಮ್ಮಿ ಬರೋವರೆಗೂ. Third step, the remainder taken in reverse order is the hexadecimal number. ಬರುವಂಥ ರಿಮೈಂಡರ್ಸ್ನ ಬಾಟಮ್ ಪೊಸಿಷನಿಂದ ಟಾಪ್ ಪೊಸಿಷನ್ವರೆಗೂ ರೀಡ್ ಮಾಡಬೇಕು. Take for example, convert 3479 base value 10 into hexadecimal. So take the decimal number 3479 and divide it by 16 according to the first step. We will get the quotient 217 and remainder 7. Again divide 217 by 16. We will get the quotient 13 and remainder 9. Hence here we can stop dividing further because 13 is reached less than 16. So 13 can be written as an alphabet D according to the hexadecimal notation. 9 can be written as 9, 7 can be written as 7. Hence we can read the position of the remainders from bottom position to the top position. That is 347 in base value 10 is equal to D97 base value 16. Next we move on to the conversion between decimal to hexadecimal conversion of fractional number. First step, fraction is multiplied by 16 and a carry is recorded in the integer position. If you take any fractional part that should be multiplied by 16 and a carriage should be recorded on the right hand side. Second step, the process of multiplication is continued till the desired accuracy is reached. The multiplication should be repeated until we reach the accurate value. Third step, reading the carry downwards gives the hexadecimal fraction. Whatever the carries that we have got, that should be read from top position to the bottom position. Example, convert 0.94 base value 10 into hexadecimal. So take fractional part 0.94, that should be multiplied by 16 followed from the first step is equal to 15.04. So the value of 15 can be written as a letter F according to the hexadecimal notation. Next, takes the previous value 0.04 into 16 is equal to 0.64. So take the value 0 and put as a carry. Next, takes the previous value 0.64 into 16 is equal to 10.24. So take the value 10 and put as a carry. It can be written as the alphabet A according to the hexadecimal notation. Next, takes the value 0.24 into 16 is equal to 3.84. So take the value 3 and put as a carry. Hence here we stop further multiplying because we have reached some accurate value. Hence the carries that what we have got, that should be read from top position to the bottom position, that is 0.F0A3 base value 16. Next we move on to the conversion between binary to decimal. When converting from binary to decimal, each bit must be multiplied by its weight, which is a power of 2, and the resulting product should be added. So take every digit of a binary number that should be multiplied by its equivalent binary weight, which is a power of 2, and the resulting product should be added. Example, convert 1011 base value 2 to decimal. So the binary numbers can be written from right hand side to the left hand side, that is 1101. For that, equivalent binary weights can be written as 2 to the power of 0, the next higher power is 2 to the power of 1, next higher power is 2 to the power of 2, and next higher power is 2 to the power of 3. For that, equivalent decimal values can be written as 2 is multiplied by 3 times, we will get the value 8, and 2 is multiplied by 2 times, we will get the decimal value 4, and 2 is multiplied by 1 time, we will get the decimal value 2, and 2 to the power of 0 is always 1. So according to the procedure, take every bit of a binary number and multiply it by its equivalent binary weight. So that is 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. So hence here we can got the value 1 into 2 to the power of 3 is 8 into 1 is 8 plus 0 into 2 to the power of 2 is 4, 4 into 0 is 0, 1 into 2 to the power of 1 is 2, 2 into 1 is 2 plus 1 into 2 to the power of 0 is 1, 1 into 1 is 1. Hence we have got the equivalent decimal value 1 base value 10. Next we move on to the conversion between octal to decimal. Octal to decimal conversion is done by multiplying the value in each position by its octal weight, which is a power of 8, and the resulting product should be added. You take any digit of an octal number that should be multiplied by its equivalent octal weight, and the resulting product should be added. Take an example, 576 base value 8 to decimal. So the digits of an octal number can be written from right hand side to the left hand side. So the equivalent octal weight can be written as 6 can be written as 8 to the power of 0, 7 can be written as 8 to the power of 1, 5 can be written as 8 to the power of 2. So equivalent decimal values are 8 to the power of 2 is 64, 8 to the power of 1 is 8, and 8 to the power of 0 is 1. So take every digit of an octal number and multiply it by its equivalent octal weight. 5 into 8 to the power of 2 plus 7 into 8 to the power of 1 plus 6 into 8 to the power of 0. So 5 into 64 plus 7 into 8 plus 6 into 1. We will get the values 320 plus 56 plus 6, that is equal to 382, base value 10. Next we move on to the conversion between hexadecimal to decimal. Each hexadecimal digit must be multiplied by its weight, which is a power of 16, and the resulting product should be added. Take every digit of a hexadecimal number and multiply it by its equivalent hexadecimal weight. So, the table, we will take every digit of a hexadecimal number, start writing from right hand side to the left hand side, that is 5, 8, A. So, equivalent hexadecimal weights can be written as 16 to the power of 0, next higher power 16 to the power of 1, next higher power 16 to the power of 2. So, equivalent decimal values can be written as 16 to the power of 0 is 1, 16 to the power of 1 is 16, 16 to the power of 2 is 256. So, according to the procedure, take every digit of a hexadecimal number and multiply it by its equivalent hexadecimal weight. A into 16 to the power of 2 plus 8 into 16 to the power of 1 plus 5 into 16 to the power of 0. So, according to the hexadecimal notation, A can be written as a value 10. So, 10 into 256 plus 8 into 16 plus 5 into 1, that is 2560 plus 128 plus 5 is equal to 2693, base value 10. Next we move on to the multiple choice question. The base of the hexadecimal number is, options are A 6, B 8, C 16, D 10. Answer is C 16. Always hexadecimal number having the base value 16. Next, second question. The number of digits in a binary number system are, options are A 10, B 2, C 4, D 16. Answer is B 2. Next, third question. Name the number system which uses alphabets as well as numerals. Options are A binary, B octal number system, C decimal number system, D hexadecimal number system. Answer is D hexadecimal number system. So, hexadecimal number system uses both the alphabets and digits. Fourth question. Which out of the following binary numbers is equivalent to decimal number 24? Options are A 1101111, B 1010000, C 111111, D 11000. So, take the decimal number and divide it by 2. So, that is 2 ones are 2, 2 twos are 4. You get the remainder 0. Again, divide quotient 12 by 2, that is 6. 2 6 are 12, you will get the remainder 0. Again, divide 6 by 2, that is 2 3s are 6, you will get the remainder 0. Again, divide 3 by 2, it is 2 1s are 2 and remainder 1. Hence, we can read the position of the reminders from bottom position to the top position, that is 1 1 0 0 0. So, therefore, answer is D 1 1 0 0 0. Next, any number with an exponent of 0 is equal to A itself, B 10, C 0, D 1. Answer is D 1. Any number which raised to the power of 0 is always 1. Next, the decimal equivalent of binary 1010000 is, options are A 87, B 80, D 45, E 50. Answer is B 80. Key answers. For question number 1, answer is C. For question number 2, answer is B. For question number 3, answer is D. For question number 4, answer is D. For question number 5, answer is D. For question number 6, answer is B. ಥ್ಯಾಂಕ್ ಯು.